In question 26, 5 moles of hydrogen are given. They are initially at STP and they compressed adiabatically so that the temperature becomes 400 degrees Celsius. We have to find out the increase of the internal energy. Dear student, the work done is equal to minus delta U in adiabatic process. Also, work done can be written as mu r by 1 minus gamma delta T. Now if we substitute the given values, this will be 5 into 8.314 into 400 divided by 1 minus 7 by 5. So this will be minus 41.5 kilojoules, and delta U therefore will be 41.5 kilojoules. And hence for this question the correct answer is option 2. Now moving on to the question 27. In question 27, when an ideal gas is compressed isothermally, then its pressure increases because, so 4 options are given to us. Dear student, since in the given case it is said that when we compress the volume, of course the volume will decrease. We know that when the volume decreases, the area will also decrease. When the area decreases, the number of collisions per unit area will increase, and this therefore will lead to an increase in pressure. This means that the correct answer for this theoretical question is option number 4. Now let us move to the question 28. In question 28, a gas is contained in a metallic cylinder filled with a piston. The piston is suddenly moved in to compress the gas and it is maintained at that position. After the compression, as the time passes, the pressure of the gas in the cylinder. Dear student, in the adiabatic compression, the gas will be heated initially, but when it is kept in the piston at a constant volume, slowly the heat will be released from the cylinder and the temperature will decrease, as we know that PV is equal to nRT. As V is constant, a loss in T, that is a decrease in T, will lead to a decrease in P as well. Therefore the pressure will decrease. Meaning for this question the correct answer is option number 1. Now let us move to the question 29. In question 29, pressure versus temperature graph for a given sample of an ideal gas is as shown in the figure. The density of gas at A is rho, then the density of gas at B will be. Now dear student, as per the ideal gas equation, we can also write that P will be equal to rho RT by capital M, where M is the molar mass. Therefore dear student, we can write down that rho dash by rho will be P dash by T dash into P, and in the numerator will be T. Now the final pressure is 4 P naught, initial temperature is T naught, final temperature is 3 T naught, and initial pressure is P naught, so this will be 4 by 3. We can clearly see that the correct answer for this question is option 2. Now moving on to the question 30. In question 30, 2 containers of equal volumes contain gas at pressure P1 and P2 and absolute temperatures are T1 and T2. The gases are joined and the gases reach a common pressure P and a common temperature T. The ratio P by T is to be calculated. Dear student, in this particular case, the number of moles of the gases remain constant. So finally, P into 2V by T, because the total volume becomes 2V, will be equal to P1V by T1 plus P2V by T2. This means that P by T will be equal to half P1 by T1 plus P2 by T2. And hence for this question, dear student, the correct answer is option 1. Moving on to the question 31.